Hi guys, tonight we're going to take a look at graphs of linear systems, and really what we're going to take a look at is how do we take these graphs of linear systems, or linear equations, the system's linear equations, and apply them to word problems. So let's go ahead and get started. So graphs of linear systems notes. There's two word problems we're going to work on, and in example 1, Sam needs to rent a car for 1 week to a trip to Oregon. He is considering two companies. So A Plus Auto Rental charges $175 plus 10 cents per mile, and Zip Auto Rental charges $220 plus 5 cents per mile. So we need to write systems of equations to represent this word problem. So for A Plus Rental, we're going to call that Y equals, has a $175 flat fee plus 10 cents per mile, and you can use M or you can use X. For Zip Auto Rental, they also have a flat fee of $220 plus 5 cents per mile. So here's our two equations. A plus auto rental is 175 plus 0.10x, and Y equals 220 plus 0.5x. And we're going to let Y equal the cost, and X is going to equal the number of miles that Sam drives, which we should have done first. Okay, so let's take a look at part 2 of this word problem. Under what circumstances is the rental cost the same for both companies? And so what the question is asking is, when is A plus rental the same as Zip Auto? Whoops, yep. So when are these two equations for A plus auto rental and Zip Auto going to be the same? Well, we know what the equation for A plus auto rental is. That equation is 175 plus 0.10x, and we know what the equation for Zip Auto is. That's 220 plus 0.5x. And then we need to go ahead and solve for x. So if we subtract 175 from each side, we get 0.10x equals 45 plus 0.5x. Subtract 0.5x from each side, we get 0.5x equals 45. Solve for x, and we get x equals 900. And since x is measuring the miles, x is equal to 900 miles. So at 900 miles, A plus auto rental costs the same as Zip Auto Rental. The second part of that equation is what is the cost. So if we plug 900 into both of these equations, we should get the same thing. So let's go ahead and do that. It doesn't matter which equation you pick. So if I take out x and I plug in 900 into this equation, or if I plug in 900 to this equation, what we're going to get for each of these is $265. So this will equal $265, and this will equal $265. So to answer the question, at 900 miles, the cost for A plus rental and Zip Auto is the same, and that cost is $265. So the third part, part B, under what circumstances is renting from Zip Auto cheaper than renting from A plus? Well, so we know that at 900 miles, they're going to be the same. But at what point is this cheaper than this one? So once the miles get to be greater than 900, because this one happens to have a smaller rate of change, when the miles are greater than 900, that's when Zip Auto is cheaper than renting from A+. And we'll take a look at this on the calculator tomorrow. It's a lot easier to see it on the calculator. So fourth part, suppose Sam rents a car from A+ and drives it 225 miles. What is his rental cost? Okay, 225 miles, is that our X and our Y? Or our Y? So go back up here, X is the number of miles. So when X equals 225 miles, we need to figure out what the cost is. So we can pick A+ auto rental, and their formula is Y equals a flat fee of $175 plus 10 cents per mile. We're just going to take out the X and we're going to plug in 225, and when we work that whole thing out, it comes out to $197.50. So to drive 225 miles with A+ rental, it will cost Sam $197.50. Okay, let's go ahead and take a look at example 2. In example 2, Maggie lives 1,250 meters from school, and Ming lives 800 meters from school. Both girls leave for school at the same time. Maggie walks an average speed of 70 meters per minute, and Min walks at an average speed of 40 meters per minute. And Maggie has to go by Ming's house on her route to the school. So we need to write an equation that shows Maggie and Min's distance from school T minutes after they leave their home. So let's take a look at Maggie first. We know that Maggie's distance to school is 1,250 meters. She's walking at a rate of 70 meters per second, or per minute, sorry. So as she gets closer to school, is her distance to school increasing or decreasing? It's decreasing by how fast she's walking. If we do the same thing for Ming, Ming lives 800 meters from the school. She is walking at 40 meters per minute. And again, as she gets closer to school, her distance is decreasing. So when we define our variables, D is the distance from school, and you can call that Y if you want to, and T is the time in minutes. And so this is really our Y, and this is really our X value. So when we look at this problem, it says when, if ever, will Maggie catch up to Ming? So we want to know when will their distances be the same? That's what this question is asking. So I want to know when will Maggie's distance equal Ming's distance. And so Maggie's distance is 1,250 minus 70t, and Ming's distance is 800 minus 40t. So I want to know when will Maggie and Ming, when will they catch up, when will their distances be the same? So when we solve for t, we get t equals 15, and t is being measured in time, and it's 15 minutes. So it will take Maggie 15 minutes to catch up to Ming. How long will Maggie remain behind Ming? Well, when the time is less than 15 minutes. Because less than that, she is still behind Maggie. At 15 minutes, she catches up to her. And the last one, at what time is the distance between the two girls less than 20 meters? Okay, so this one is easiest to solve on the calculator. There's a really easy way to do that. So tomorrow in class, we're going to take a look at the TI-84 and how to solve this problem. But if you can figure it out in the meantime, that would be great. So we're looking for when is the distance between Maggie and the distance between Min, when is that going to be less than 20 meters? So, and again, the easiest way to figure that out is on the calculator, and we will take a look at that in class tomorrow. Okay, now it's your turn to answer some questions on graphs of linear systems. Multiple choice. Solve the system by graphing the two equations on your graphing calculator and finding the point of intersection. If you don't have a graphing calculator with you at home, you can do it on Desmos, you can do it on a free graphing calculator, and you're trying to find their point of intersection. In question number 2, for his parents' anniversary party, Eric is considering using one of two venues. The Wild Grove will cost $150 for the reservation plus $35 per person. A restaurant in the same city will cost $5 per person in addition to $450 for the reservation. In order to make the best decision, Eric figures out how many attendees it would take to have the venues cost the same. So they are going to cost the same amount. Using your graphing calculator to determine how many attendees that would be. You can use your graphing calculator, or you can use just use substitution, elimination, or just graphing it on the calculator. So be sure to answer your questions in the Google form. And if you have questions, please ask. But we're going to practice with these types of word problems and how to use them on the calculator, or how to solve them on the calculator in class tomorrow and next week.